Hello, everyone. Welcome to Web Hacking 3. Here's the meeting flag for those of you participating in Pwny CTF. It's script alert 1 script. It's a very common web injection where you just inject a script tag alert 1. And if it works, then you know that you're running your own code on their servers, and that's always good. Okay. The meeting file will come back at the end as well, so don't worry if you missed it. All right, so quick overview for today. We're going over command injection, template injection, patch reversal, and SSRF. So starting with command injection, this is where a user can input shell commands that run on the server, and so therefore they can access files or any sort of environmental variables, etc. So one example is web application calls external scripts and passes in the arguments. So for example, if you've ever used those tools that download videos off YouTube, they will tend to just take your argument and then put it in the shell script. And then you're just running stuff in their shell, so you can do whatever you want. It's similar to SQL injections where user input works by escape the quoting and then inject your own arbitrary commands. Some common things you would use are just put semicolon or and to run multiple commands in the same line. If you know good bash, then there's a lot of tricks that can get you far in these challenges. So one example, this would be a function that runs on the servers. It's called cause. So it takes the input and then if you look carefully in the command, it just takes the user's input and then it just adds it into the command with nothing checking like, oh, did they put anything malicious? So then they literally just run the command in their OS. So you could literally just put in a semicolon and then, or in this case, an and it will then run cat flag.txt as well, which means it will also print out the flag, as you can see in the photo. So next up, we have template injection. This is where the user injects the template syntax to execute code. So starting with a general overview for templates, web templates are very similar to static files, but they can incorporate variables and expressions. This is most common if you've worked with Python and Flask, Jinja, those types of things. So this one, I believe, is an example of Jinja templating, where you can put in 2 curly braces, and then you can start using like Python expressions and variables. So that when the server renders it, it goes, okay, I recognize this as an expression. Let me put in what that value is on my side. Generally, there's support for statements and expressions. Again, the main example being Flask and Jinja. A very common, like if you want to see if they're using templating, you can inject something like the 2 curly braces 7 times 7. If it then renders as 49, wherever you're getting the output, then you know that they are running your code in their templates. And this also means you can put whatever Python code you want inside of that. And if you guys were there for PyJail, if you can access anything in Python, you can access everything in Python. So we mainly work with Jinja, but there are some other templating places. Jinja just tends to be the most common one because people who are building in Python and Jinja, like myself, will not think about this. I actually went back to an old project and found out that I was vulnerable to this. I did not fix it yet. Don't look at my website. But yeah, so some available variables that you would want to look at are like config or request. With config, you can access a bunch of like environmental variables. So for example, like the flag can be stored as an environmental variable, and then boom, you just have it. Request also, because then you can send requests from their server, so you can pretend to be their server, or you can, if they're like not outputting, if you're not getting the output directly, you can send a request to like your own website, where then you can see the request and what the content of that is. So here's another example in Jinja or this one's Flask and Jinja, where they just take the user's name And this is actually the exploit. Well, this isn't the exact code I had, but this is essentially the exploit of my website where I just template user. And so if you put malicious code as your username, it will just run on my server and then boom, you have access to the entire server. So be very careful with these types of things. Or pray that the people you're trying to hack into are not careful with these things. So yeah, one example is you could just make your user curly braces 1+1, and then if you see that the user is now 2, you know that they're running your code. So you can also try testing this locally on your own servers. Put in like the user equals, and then put in like some sort of template injecting, and then you can see that it will literally give every single environment flag in this case. So any secret keys you have, for example, ChatGPT tokens, will become publicly available. And we wouldn't want that now, would we? And of course, you can take this even further because if you guys have done PyJail, if you can access one thing, you can access everything, including the OS, meaning you can run whatever bash you want on their servers. So this is a bit of an extreme example, but yes, if you want to access every single global, there's a lot of them in Python, but it shows just how much stuff you have access to with Python. Thank goodness every beginner programmer uses Python, including me. Okay, so the next method is called path traversal. This is where the user uses ... to get to access certain files that they're not supposed to normally. So just as a quick overview of Unix paths, generally it goes slash the folder slash folder slash folder until you get to the file name that you want. However, generally people forget that you can actually go backwards in these. If you add on ... it then goes back one. So in this example, if you look at my lovely images, the person who's like programmed this, they're like, okay, I'm only letting them access files in my directory. They can't access anything else, right? However, if you put the slash, then they can now go back one directory, and so they can access all of your code files. They go back again and again and again, and eventually you get to the root, meaning you have access to literally everything again. Python is not safe. So yeah, and especially if you know the name of the file path, like in a lot of CTF challenges, it'll be like flag.txt, or they'll usually tell you, but it'll be something like that, and so you can just read it out. All right, now I'm handing it over to you.
Okay, so I'm doing a server-side request forgery. So that's accessing the private resources using the server. Like you make a request to the server makes a request to a third party, and hopefully the server only can access public IPs, but normally that's not implemented very well, and there's a lot of reasons why that happens. So the idea is it returns the data from like an internal service that's that's impossible for the end user to access. So like you can have like HTML to PDF image renderers, anything that really takes a link and then sends a request to it. There's a lot of examples of this, like external resource imports, refer headers. Like sometimes people will misconfigure their proxy server, so it looks at your like refer or your host header, and it will send a request there and figure out what's going on, and then route it. But that's actually, you can just substitute, say, send host as localhost or something like that, and it will send the request to there. Other stuff, Discord image bots. That's actually what I've done before. So the idea is you have like an attacker here who can make requests to your web server. And the web server has something on its like internal network that you're not supposed to access normally, maybe a router or switch, modem, or maybe like the AWS endpoints, which you can actually use to like completely take over a server. So you make a request for something that tells the server to make a request to this. Normally it only should make requests to the public internet, but in this case it doesn't. It'll send you your response, and then the response will come back to you, and then you get access to whatever is behind there. So the idea with SSRF, the impact is you can like do internal port scanning. You can look for services running on other internal ports or on internal IPs. You can enumerate their entire network. You can do a local file inclusion. You see this sometimes with like when you're running like PHP and they do like make a request. PHP doesn't disable the file protocol, so you can just read files off using like file links. You can, and again, like you can use AWS does this. A lot of web servers use this because it becomes sort of a standard. You can access the metadata, and then in some cases, if they're using like an old version of the AWS metadata server, You can access their access token. Once you have their access token, you can create yourself a new VM, and then start attacking basically everything on their internal network. Other stuff like database HTTP interfaces, you can do as well. So the simplest idea is you get a URL from the client, and then you send a request to there. And normally it's like, okay, I send it to like google.com, it'll take a picture of google.com and print it out for me. But then if you do something like this is a local network, it will fetch like this address, which is on the local network, which you shouldn't be able to do. But this is pretty simple because a lot of people won't actually implement this. Like they'll think about it a bit and realize they don't want this. So if you have something like this, very simple filter, just checks if it's not this, tells you no. So if you try this, it won't give you the answer. But then there's a few tricks you can use to get past this. So first you encode part or all of the URL using like these %, so you can obfuscate like the flag. The other trick you can do is you can output the IP as this number instead of the actual IP. And the reason for this is in base 10 what 10.0.0.2 is in base 256. And you can do this with actually various different types of encodings. Like this is octal encoding, this is base 8, so you use 0, 0, and then the numbers are 12 in octal is 10. And then the other thing you can do, sometimes you can use hex. So this is the hex representation of the IP address, which is the same thing. And then if you request this, some HTTP clients like Node.js actually do resolve this back to what it originally is, and then you'll be able to get through with a bypass. There's also other tricks. So instead of using a that type of obfuscation, a lot of places will automatically assume that if you can point your DNS server at an IP address, you must logically own that IP address, and nobody can own localhost. But that's actually not true. DNS is just a lookup table. You can put whatever you want up there. So you can use something like spoof.burpcollaborator.net. That's like from Burp Suite. It'll point to localhost, so you can access that. 1u.ms is really useful for doing this. So you have like make1234.r and 1u.ms actually points at 1234. And then you can also exploit like partial differentials. So maybe your thing checks if it starts with http://safesite.com. So then the trick here is this is the actual domain that it's being sent to. This is the authentication thing. So it's creating a username safesite.com and the password is A, and sending that with HTTP basic authentication to localhost. And ideally, your server will ignore this, and then you can get access to what you want. But what if it gets even more intense? And this is code that I actually have written and deployed in the past, my own code, where essentially it parses your URL, gets the host and port, and checks if it's a safe IP. I'll presume that this checks like all of the private ranges, all of the other ranges they don't want you to see, and then it makes a request to whatever you want it to make. And this is actually unsafe for an interesting reason that people, including me, assume that a DNS to IP address that's pointed to by DNS can never change, or at least it doesn't change very often. Maybe changes once in an hour, and every web developer's had a problem like propagating their DNS records like AWS did for a very long time. So they would assume that it always stays the same, but it's actually not true. So if you think about what happens when I type like domain.com, the server first looks up domain.com and then checks the IP address. So maybe if it points to like something on the open internet, then it's like, fine, I'll do it. But then the second time it looks it up again and it sends the request to the IP address returned, which doesn't have to be the same IP address. So normally these are the same because it's cached and then it's stored in like your computer's cache, or maybe it's stored in like your local resolver's cache or something like that. Along the way, they're the same. But you can actually do this trick where you control an authoritative DNS server, so you have the full authority to declare what you want, and then you have the first response be a safe IP address with like TTL0. So you say like 1.1.1.1 TTL0. So it looks, it says, okay, you're actually accessing something on the open internet, which is perfectly fine. But TTL0 says immediately revalidate, never assume that it's can be cached. So then when the second request comes into your authoritative DNS server, you're like, now I will send you 127.0.0.1, and then it will send a request there. So this is also done with 1u.ms. It's a really useful tool. So you have something like make1234 where you find this 1u.ms. So first request returns 1234, which is safe, and then the second one returns your internal endpoint. And 1u.ms is actually really powerful because you can do like, let's say it tries it 3 times in a row. You can just tell it to return this 3 times in a row and then return the second one. There's actually a lot of other useful things. You can check it out on the GitHub. You can also like see the requests as they're coming in. So you would put like your own name before this, and then maybe not your own name for OPSEC reasons, but you put some kind of identifier, and then you can like they have a live stream, so you can see like, okay, it's making 5 requests, and then it's deciding to trust it and making the last request. So then you can see, okay, we'll just configure it that way, or maybe it's like waiting 2 seconds or something like that. That tries to prevent this kind of attack, but you can only prevent it really, and this is rather difficult. First, make a DNS lookup to the pay URL you want, and then forcibly cache that DNS lookup, and then use that as the IP address when you send the request. And then this is complicated by the fact that you actually have to send the host name, and a lot of HTTP clients don't really support this. So a lot of people get it wrong at this stage. Yeah, I think that's it for this meeting. Next meeting is this Thursday, or next Thursday actually, for Crypto 3 block ciphers, and then this Sunday we have Java Red.
Oh, wait, correction. That's not just Sunday. That's
Yeah. The Sunday after the next Thursday.
Use the dates, not the.
Yeah. So for practice, you can have there's SSRF challenges. There are like several levels of this. There's path traversal. There's template injection. Yeah. And then this is the meeting flag, and as always, meeting content is uploaded to sigpwny.com/meetings, and there's a YouTube video so you can watch the video again if you